thanks very much, Ken, for that warm introduction. I'm delighted to be back here this evening. I think I'll wear a suit. This is the first time I've worn a suit for a year. But I thought I might be talking to an audience of 3 or 4 people because the publicity was a bit late. So I'm delighted to see so many of you here this evening. That's really great. Now, it's not a very catchy title for my talk, Alternative Fuels and Advanced Vehicle Technologies towards Zero Carbon Transport. But the reason for that title is a book. And I'm not trying to sell the book, but this was the first edition that I edited in 2014, so 8 years ago, quite a long time ago. But I'll explain the background to how I got involved in that and why I'm talking to you about this subject this evening. Prior to becoming president of the Institution of Mechanical Engineers in 2015, I was the chairman of the automobile division of the IMechE. And when I was chair of the automobile division, I was talking an awful lot about climate change and the need to reduce carbon emissions. I went over to the US and talked to the SAE about that subject. I gave a guest lecture at the SAE Congress in Detroit. And in those days, that was kind of the mid-2006 to 10 period, we still had a lot of climate change skeptics around. And I'm still surprised, I still meet climate change skeptics today. And I've been fairly convinced by the needs to reduce carbon dioxide emissions and that climate change is real for probably about the last 20 years. And the most convincing argument I heard was from a guy called Professor David King, who used to be the government chief scientist advising on transport and climate. And he said, well, the climate skeptics might be right. It might not be man-made, and there might not be anything that we should be doing about it. But we don't really know that. And if we were going to take a gamble, and the stakes of the gamble are the future of the planet, on balance, it's probably better to reduce carbon than not reduce it, on the off chance that the climate skeptics are right. So on balance, I think I'd rather reduce carbon just in case the climate scientists are right. Now, there are some really great books on climate change, and some of them have been around a long time. This is one called Heat by George Monbiot, talking about the consequences of climate change. And there's a much better book than this that I didn't manage to find in my library called 6 Degrees, that talks about what happens as the planet warms by each half a degree. There are 12 chapters, and it goes from a half a degree warming through 1 to now the latest very topical COP27 target of 1.5 degrees. And then it starts to get quite scary, even at 1.5 degrees. When you go over 2 degrees, it gets really scary, and a lot of the planet becomes uninhabitable. And the real risk with climate change isn't that when it's all a bit warmer, but you get large areas of the planet that are no longer habitable for human beings. They just turn to desert, you can't grow food, and there's mass water shortages. And then you get mass migration to the more temperate areas where the entire 7 billion people on the planet, or 9 billion people by the time it happens, are trying to live. And that's a very, very worrying scenario. So that's why I've been taking climate change seriously for such a long time. Now, way back when I was chair of the automobile division, a very, very highly respected group was asked to write a government report on low carbon transport. And this was called the King Review. And this was actually published at the IMechE in London in Birdcage Walk in March 2008. So quite a long time ago. 14 years ago, we were already talking about it. And Professor Dame Julia King, who was Vice Chancellor of Aston University, now retired, is a really clever woman, a very, very highly respected scientist. And just by total coincidence, she's married to Dr. Colin Brown, who was the Director of Engineering at the IMechE. but that is a coincidence. Their professional paths don't tend to cross that much. But Dame Julia King came to the IMechE in Inverted Walk and presented this report along with a very, very influential economist called Nick Stern, Professor Nicholas Stern. And he's a really highly respected economist as well. And he made the point that if we don't tackle climate change in the near term, it's going to cost us far more economically to mitigate the effects of climate change longer term than if we spend money on fixing it now. And I think that's another really important perspective on what I'm going to talk about. It's better to spend the money on tackling climate change now than trying to mitigate all the disastrous consequences when the temperature goes over 1.5 or 2 degrees rise. So Dame Julia King presented this report, and in summary, it says the answer is electric cars. That was what she said. It's all electric cars. And as chairman of the automobile division, I didn't quite agree with that. Not because I think it's the wrong technical solution, but because it carries a lot of issues with it. So in 2014, I was approached by a publisher called Woodhead Publishing, and they said, would you like to write a book about alternatives? Because while I think electric vehicles are a really important part of the solution, they're not the whole solution. And just one statistic for why they're not a solution is there are about 200 million vehicles in the world that run on fossil fuels. And even if we all switch to electric vehicles, they're not going to go away by 2030. New cars might be electric in 2030, but what are you going to do about those 200 million legacy vehicles that are still burning fossil fuels and emitting carbon dioxide? So I thought there was a good place to write about all the alternative fuels. There are lots and lots of technologies, and that's really the point I was always making as chairman of the automobile division. While electric cars are a technology, there are many, many, many other technologies that can play a role in decarbonising transport with both alternative fuels and advanced technologies. So I wrote this book, well, I edited it, there's about 22 chapters in this, and it was published in 2014. So a long time ago, 8 years ago. And it's been a good seller, actually. It's been a top seller in its field. And it seems to be well received by government officials and university students and people like that. It's sold all around the world. And I belong to a thing called academia.com, and it tells me how many times it's been cited in papers, and it's many hundreds now. So it's been quite influential. But I'm not here to try and sell the book. I want to tell you about what it says. So that was a success. And then last year, might have been the year before, Woodhead had been bought by a much bigger publishing company called Elsevier. And they said, do you think it's time for an update from the book that was published 8 years ago on these alternative technologies? And I said, that seems like a good idea, but it was a lot of work producing this. It's about 800 pages long. I said, I don't really want to do that all on my own. So I asked a friend of mine, a guy called Steve Sapsford, who's another IMechE member, and he's the chair of the powertrain systems and fuels group of the IMechE. So he's an expert on fuels and internal combustion engines. Used to work for Ricardo, and I asked Steve Sapsford to split the work equally in an update. And what's been interesting is how much has changed in the last 8 years, how much more we know. So what I'm going to talk about today, I definitely don't want to try and sell the book, and this is very expensive, by the way. This is £284. This one's 316. So don't steal them, please. Any copies? It's a very expensive book, and the online edition is the same price as the paperback edition. So it is expensive, but it is very comprehensive as well. It covers the subject in great detail. And what I'm going to talk about this evening is I'm just going to run really quickly through the topics of each of the chapter titles, and that will give you an idea of all of these multiple technologies that we could employ to reduce carbon dioxide emissions and other pollutants on the way towards zero carbon transport. What we'd all love, I was saying this 20 years ago, is we'd love to have a car that just runs on water. And maybe hydrogen fuel cell cars are getting close to that. A car that runs on water and is completely pollution free. But we'll talk about that in a while. So I'm going to run through all the 20 odd chapters in here. One of the big updates in the new book, which wasn't in the original, is there's a good chapter at the end on autonomous vehicles and the role that self-driving cars can play in reducing pollution. I'll talk about that a little later. So just a bit of background about me. Oops, what's gone wrong now? Gone off the screen. Oh, there we are. Didn't like the images, I guess. Just a bit of background about what I worked on at Ford. I did lots of transit programs. I've done 5 transits and was the program manager for the previous transit, which we engineered in the US. I spent 3 years working in Detroit and Dearborn on the transit. Then I came back to Europe and was the project manager for the original Ford Focus. So my CV reads project manager, best-selling van in the world, best-selling car in the world, which is not too bad, I don't think. And then I was the chief engineer for global engineering standards across all the Ford-owned companies. So my business card said chief engineer, Ford, Jaguar, Land Rover, Aston Martin, Volvo, Mazda, which is another, bit of polishing the ego piece really for me, but I enjoyed that job. And then in 2006, I got that proverbial offer that was too good to refuse, and I chose to take early retirement on my 51st birthday. And since then, I've been working mainly for universities, doing a lot of lecturing in automotive design at Hertfordshire and Loughborough, and I do a lot of work for the government for Innovate UK. So I was president of the IMechE in 2015, and this was the title of my presidential address that year. From steam engines, because that's what got me interested in engineering when I was a child. I wanted to build a live steam locomotive that would run on the local miniature railway track, and I actually managed to do that eventually. So self-driving cars, and I covered all the technology in between. And Henry Ford's was an honorary fellow of the Institution of Mechanical Engineers. And I always think it's quite interesting that Henry Ford was a great future-looking entrepreneur. We had a number of famous quotes. I loved a lot of Henry Ford quotes. I'll give you 3 of them just off the cuff. Any colour you like as long as it's black. Well, that's because black was the fastest drying paint, not because he wanted to restrict customer choice, but he wanted to speed up his production line, and the only colour that he could get drying quickest was black. That's why it was only any colour you like as long as it's black. He also used to famously say, if you're not going forwards, you're going backwards, which I think is a good quote. And if I'd asked my customers what they wanted in terms of new technology, they'd have asked me to build them a faster horse. So he was a very forward-looking, visionary man. And it'd be interesting to know what he would make now of our pursuit for carbon-free transport, getting towards zero emissions. This was the first edition of the book that I talked about, published in 2014. And it was really written as a response to the King Review that said, the answer is electric. And my answer is, yes, that's part of the answer, but there are many, many other technologies. And that's what I'm going to talk about. So this is repeating what I've said. And my question is, what about the alternatives? And now we've just got to the second edition of the book, which was published in September. And it's very topical. We kind of tried to target it for COP27, because that's what's going on right now, is what COP27 is all about. How are we going to get rid of the carbon emissions worldwide? So I edited it with Steve Sapsford. You've heard about my background. Steve was Director of Business Strategy at Ricardo. chairman of the IMechE Combustion Engine and Fuels Group, it's now changed its name, and he's a visiting professor at Cardiff. So I'm going to go through the 23 or 4 chapters of the book and talk about what all the technologies are very briefly. So I wrote the introduction, which very much talks about the fact that there are multiple alternative technologies and we shouldn't discount them. And what I'm worried about is putting all of our eggs into the electric basket. I definitely believe electricity is part of the solution, but if that's the only game in town, we might be missing great opportunities. The next chapter, and a very large part of both the books, is the role of alternative and renewable liquid fuels in environmentally sustainable transport, and the key challenges of blending those fuels. Now, you can make synthetic fuels quite effectively. Biofuels are well known from biocrops, but you can also combine gases from the atmosphere. You could extract CO2, combine it with nitrogen and make synthetic organic compounds that replace fossil fuels. Fossil fuels are quite energy efficient because they have so many carbon and hydrogen atoms within the molecules of the petroleum. But you can replicate other organic compounds that also make good use of hydrogen and carbon, maybe some nitrogen and ammonia, to make other types of synthetic liquid fuels, and I'll talk in a moment about gaseous fuels. Now, Jamie Turner is a real fuels expert. I've known him for probably 25 years. He used to work for Lotus, and Lotus many years ago built a Lotus Elise, I think it was, that was a tri-fuel car. It could run on petroleum, synthetic fuel, a mix of ethanol and other fuels, and fully synthetic fuels as a demonstration. And his co-author is Felix Leach, who's a very influential lecturer at Oxford University. So a large chunk of the book talks about synthetic fuels, e-fuels, which are effectively liquid organic fuels made from electrically combining chemicals together, which is why they're called e-fuels. And there are lots of alternative liquid fuels that could be used. Now, that's really important because, as I said, there are 200 million vehicles out there around the world running on fossil fuels. And when we get to 2030 and new internal combustion engine vehicles are banned, those 200 million vehicles are still out there. They still need to be fueled, and they'll be used for another 20 to 30 years, many of them. So we need to find a low carbon alternative to fossil fuels for the existing fleet. That's really an important part. And Julia King didn't address that question. You can then use the synthetic fuels to improve the environmental performance of internal combustion engines and blend them together. And the book actually splits it into 2 chapters, one more on biofuels and the other on synthetic fuel. Then you can apply the same sort of thinking to gaseous fuels, methane, ammonia. Now, methane is not good because that's a greenhouse gas in its own right. You can use methane to combine it in other ways to make a more environmentally friendly fuel. And there are lots of other gaseous fuels that you can use as well as liquid fuels. The problem with gas is it's not quite as energy dense in volumetric terms as a liquid. So you can make them from lots of different things. Synthetic fuels made from coal. Syngas has been around for decades. E-fuels, which are electrically synthesized artificial fuels. Lots of biofuels from crops, bio-waste, methane, alcohols, ethanol, methanol, biodiesel, bioesters, ammonia, and liquid fuels made from synthesis of CO2 in the atmosphere. So this would be a very virtuous technology if you could do it at scale to absorb CO2 back out of the atmosphere and turn it into a synthetic fuel. The problem with CO2 in the atmosphere, we always talk about CO2, is it's actually a tiny percentage of the atmosphere. Oxygen's 18%, nitrogen's about 27%, rare earth gases are a couple of percent. CO2 has gone from 0.01% of the atmosphere to 0.5 now of a percent. It's still a tiny percentage of, no, sorry, 0.25, we're about 0.25 of a percent of the atmosphere is CO2. So although we're worried about it, it's actually a very small fraction of the atmospheric air. The next chapter, which I wrote with a guy called Andy Atkins from Ricardo, again he used to work at Ricardo, is on electricity and hydrogen as energy vectors for transport. There's no naturally occurring hydrogen, but you can use hydrogen to transfer energy from one source, like electricity or solar or wind, store it, and then convert it back into mechanical motion in a vehicle through either an internal combustion engine, a hydrogen fuel cell, or other means of converting the hydrogen back into mechanical energy. One of the interesting things about the book, we actually wrote different chapters with different perspectives. So Andy Atkins wrote one part of the chapter, and then I wrote a separate chapter just on hydrogen as an energy vector for transport vehicles. And I talk a lot about how do you produce hydrogen. There are lots of different descriptors of hydrogen now. Black hydrogen is made from fossil fuels, and that's where most of our hydrogen comes from today, about 90%. Brown hydrogen, which is kind of cleaned up black hydrogen. Green hydrogen, which is from renewable sources, and typically wind turbines or solar making electricity that you use for electrolysis, and there are no carbon emissions associated with it. That's why it's called green hydrogen. Or blue hydrogen, where you make it from a non-renewable source and you sequester the carbon by burying the carbon dioxide byproduct in the ground. So there are lots of different descriptors of hydrogen. It's quite confusing. But the end result is always the same. One of the complications with hydrogen is for fuel cells, it needs to be 99.99% pure so you don't contaminate the chemicals in the fuel cell. And that's a challenge in itself for hydrogen fuel cells. So many people see the long-term future as being hydrogen, but there's really divided opinion on the merits. And I'm not quite sure where I come out. It's really expensive. 90% of our current hydrogen comes from fossil fuels, normally from steam reformation from natural gas, but then you get CO2 as a byproduct. And many people say it's more efficient to use the electricity that you'd otherwise use to electrolyze water into hydrogen and oxygen. It's more efficient to use that electricity directly to propel the car in Julia King's electric cars than it is to turn it into hydrogen. You get 90% energy efficiency using the electricity directly, only 45% efficiency if you turn the electricity into hydrogen and then back into energy. And electricity is moving towards renewable sources. About 50% of our electricity here is now produced from wind turbines, solar and wave power. And some people count nuclear as renewable. There will be arguments about that. I'm sure Gordon have a perspective on that. And one of the problems with nuclear is, although it might seem like a renewable source, because there's no CO2 emissions from the nuclear power station, there's an enormous amount of CO2 emitted from the millions of tons of concrete used in the construction of the nuclear power station. Some people say that 30% of the total energy emissions from the power station is emitted during its construction. So lots of issues around hydrogen, and I'm not sure where I come out. I have a kind of personal bet with myself. I get a company car from Ford throughout my retirement. I'm still waiting to be offered an electric car, so we haven't quite got there. I drive a hybrid. I've got a hybrid at the moment, which is fantastic. That's a a 2.5 litre petrol that does 52 miles per gallon. So we're making progress. I've not yet been offered an electric. My rule of thumb is electric cars are double the cost of an internal combustion engine, and hydrogen will be 3 times the cost because of the cost of storage. And my personal bet is I won't be offered a hydrogen-fueled car by Ford while I'm still able to drive. Now, I've modified that slightly recently, and my new definition is I won't be offered a hydrogen-fueled car by Ford while I'm still able to drive it myself. I might get a self-driving one when I'm in my 90s, but not while I'm still compass mentis to drive the car myself. It would be interesting to see if I'm right about my predictions. The next chapter is on advanced engine oils. This might seem a bit peripheral, but you can do a lot to improve internal combustion engine efficiency with additives, oils, and cycles and concepts, which are what these 3 chapters are about. These are all worldwide experts, all the people I know from my time in the automotive industry. Keith Howard works for an oil company called Lubrizol that makes lots of additives. John Bennett was the fuels specialist at Ford before moving to Saudi Aramco. And Jocelyn Johnson and Jeff Neighbour work in the University of Michigan on internal combustion engines. And there's still a lot we can do to improve the efficiency of internal combustion engines before they're completely obsolete. I used to say to people, if you love internal combustion engines, as I used to like working on them, don't worry, they're still going to be around for the next 10 to 20 years. I know many companies stopped developing them, but there's still more that we can do. Now, the UK has banned direct sale of internal combustion engines from 2030 and in hybrids from 2035. Still a little way away, but that's not really very far away in automotive company development terms. It's only one cycle of new product. There are still further improvements we can make for the next 10 to 12 years. So the internal combustion engine is not quite dead yet, even though the writing's on the wall for it. You could then burn your hydrogen in an internal combustion engine. And one of my ex-colleagues who was the director of research at Ford said, I really can't see why, if we've got cheap, plentiful, renewable hydrogen, you'd go to the trouble of developing new technology like fuel cells, which are relatively unproven, fairly new, still in their infancy, versus burning it directly in an internal combustion engine where you get virtually 0 emissions, and it's a highly developed, proven technology with all the infrastructure to make them in place that we've been manufacturing for the last 130 years, which is a very valid point. So it's interesting to see whether the government allows hydrogen in internal combustion engines, particularly for heavy trucks, which we'll talk about in a moment. We get on to heavy-duty vehicles. This chapter was written for heavy vehicles. They're a real challenge because of their weight and power requirements. I started off my career at Ford working on heavy vehicles, and the interesting thing about those is the engine tends to work at 100% output or you're braking. It's a bit like a racing car, that you need all the power for climbing hills, and you need an awful lot of power for climbing hills in a heavy-duty vehicle. And it's much more challenging to get them to 0 emissions than a car. And the amount of battery power you need in a truck is quite amazing. I have recently done an Innovate assessment on electric powertrains for heavy trucks. Some very interesting proposals, things like swapping trailers every few miles with new tractor units that are fully recharged and fast charged. There are some good ideas, but heavy duty vehicles are a real challenge. Alan Tully used to work for JCB. And then he talks about the future of internal combustion engines for heavy duty vehicles. So that's a really interesting challenge for the future. What are we going to do about heavy transport? It's much harder to switch entirely to electricity. Urban trucks, yeah, we're pretty much there now. MAN, Scania, Volvo, they're already selling electric trucks for urban cycles, lots of stop-start, relatively short distances, maybe 40 to 50 miles during a day's duty cycle. You can do that. You can package enough batteries in the truck to get back to base and recharge overnight or in a few hours. Long distance needs a different solution. Maybe hydrogen in fuel cells as a gaseous fuel in internal combustions, and there isn't really a clear answer yet. I know JCB are backing hydrogen. Lord Bamford, who I actually did some work for Lord Bamford, and he asked me, what's the future of hydrogen? I wrote a paper about hydrogen and hybrids, and he obviously took it to heart because he's backing hydrogen now. You could go for overhead catenaries, overhead wires like trolley buses or trams. Very, very costly to put those up the motorway for long distances, and interchanges are quite difficult. So heavy duty vehicles, really tough, no clear answer at the moment. Then we get to light weighting. Weight is the enemy. Interestingly, Sir Isaac Newton was right. Force equals mass times acceleration. The higher the mass, the more force you need to accelerate it. So part of the answer is make everything as light as possible. Then you need less force, less power, and you can go further for the same amount of energy. So we've got chapters on conventional advanced materials to make combustion engine materials lighter, stronger. Although Kamil Markamov is actually Russian, he works at the University of Lancaster, so he's not there at the moment. But he did insist in his chapter in using lots and lots of Russian standards for materials that he specified, but we'll let that ride. Advanced transmissions can help to improve overall performance, reduce losses, and sustainable design through lightweight vehicle structures. Glenn Dane's a lecturer in the US on lightweight vehicle structures, things like carbon fiber instead of steel. Steel is still a relatively efficient material in terms of strength per kilogram. And unless you're making your vehicle very, very thin and not needing very much strength, steel's still competitive with aluminium in lots of cases. Aluminium is not the single answer for lightweighting. But there are lots of new materials coming along, so lightweighting is an important element of this multifaceted challenge. Then you can improve rolling resistance and aerodynamics. Kevin Chow's an aerodynamics expert from MIRA, the Motor Industry Research Association in Nuneaton. We didn't really update this next chapter on mechanical and electrical flywheel hybrids. Keith Pullen's a lecturer at City University. And when we did the first edition of the book in 2014, there was an enormous amount of excitement and enthusiasm about storing energy in flywheels. A friend of mine who was the president of the IMechE after me started a company called Flybrid, making high-speed flywheels that spin at 60,000 RPM in a vacuum to absorb energy and then give it back when you're accelerating. He sold his company for a vast amount of money to another company, which then went bust. And flywheel technology seems to have gone down a blind alley, really. It doesn't seem to be getting anywhere. Similarly, hydraulic and pneumatic hybrids seemed to be an idea in 2008. Saw around the Philippines an expert in those, but flywheels and energy storage doesn't seem to be the flavour of the month at the moment. It might come back. Then you can recover a lot of energy from regenerative braking. My hybrid Mondeo recovers a lot of braking energy, and it's interesting, it's never done less than 52 miles to the gallon, which is amazing for a 2.5 litre petrol car. And if I look at the energy monitor, more than half of my driving is on pure electric mode, where it's recovered energy during braking, gives it back during acceleration and cruise, and about 53% of the drive time is in pure electric mode from the battery, which is in the boot. Then we have a chapter on battery technology from Neil Johnson, worked for Johnson Matthey in the US. Battery technology is an area that has advanced enormously in the last 8 years. Loads and loads of developments in battery efficiency, durability, lifetime, range. It's a very extensive chapter. There's a lot going on battery technology, and then a second chapter on lithium-ion cells in particular, and other emerging storage technologies. Things like solid-state batteries seem to be very topical at the moment. So there's loads and loads and loads going on batteries. And as I said, electric vehicles, batteries are part of the solution, but they're not the only solution promoted by Julia King. I've already quoted Newton. Weight is the enemy. Weight and friction. More mass and friction means more fuel used, and hybrids can recover some of that. So that's the reason for talking about these technologies. There are plenty of electric cars and hydrogen cars out there, and electric cars have really taken an enormous chunk of the market. They're now about 10 or 11% of new vehicle sales, and when I wrote the first edition of the book, they were less than 1%. And in the first edition of the book, I said, ever since 1904, when electric drives were the dominant technology in Detroit with a car called the Brown Electric, that was an electric car before the starter motor and the transmission and clutch were invented. Ever since then, engineers have been saying electric cars are going to take over in the next 10 years. And I wrote in the book, I said there's the Folkson constant. It doesn't matter when you look at history, electric cars are always going to overtake internal combustion engines within the next 10 years. They might eventually, but that's still true now. We haven't got there yet. Electric cars are about 10%. They're not more than 50% to get to the overtaking internal combustion engines. And they're still very, very expensive. My view is electric cars are really a product for the relatively wealthy. In normal terms, an electric car is double the cost of a conventional car. My brother-in-law's got an electric Fiat 500. He loves it. He's affluent. His electric Fiat 500 costs £30,000. The Tesla Model S is £80,000, and you can get a very, very nice petrol Jaguar or BMW for £40,000. So electric cars are expensive. Fuel cell cars are even more expensive. The Toyota Mirai, when it was launched, I've driven 3 of them. The Toyota, really impressive car, very nice. It's a kind of Focus-sized, it reminded me of a Focus family saloon, very competent car, very, very nice, £66,000. And when I drove, it was a few years ago, but I've driven 6 hydrogen fuel cell cars, and at that time, that was 20% of the UK population of hydrogen fuel cell cars. So they are really expensive, and again, you've got to be affluent to afford them. Even second-hand cars coming onto the market, if you are really keen on having an electric car, will be about the same price as buying a new internal combustion engine car. I think the Ford Mustang is about £50,000. That's still an expensive car for an electric drive, and it's certainly beyond my means. Even though most cars are leased now, you're still talking £400 to £600 a month as a lease price for an electric car. That's a lot of money. And that's why it's going to take time before we get to affordable electric cars that Mr. Average, with his average salary of £26,000 a year, can afford to buy. That's the challenge. It's all about cost. Let's just talk a little bit more about electric drives and storage. Lithium-ion is currently the best solution we have for batteries, but there are real concerns about the finite resources needed to manufacture the battery. And it's so energy intensive to extract the minerals and then turn them into a battery, then it's calculated that it would be equivalent to 2 years of fossil fuel usage in the car, 2 years of diesel or petrol in your vehicle, to balance out the energy and emissions just to manufacture the batteries. So they're not a completely zero emission solution. You've still got a lot of emissions before you start getting a zero emissions payback after a couple of years. And they're double the cost of a conventional vehicle. Most consumers spend around £1,500 to £2,000 a year on fuel, even at today's high fuel prices. So it takes you a long, long time to break even on your twice or 3 times as expensive low carbon vehicle with fuel savings. I calculated that comparing a diesel Ford Focus with a Nissan Leaf would take 10 years to recover the added capital cost of the car before I'm getting a payback on my fuel savings. And that was with the £5,000 government tax rebate for electric cars, which, oh, by the way, they've just taken away, and they're now talking about taxing electric cars with vehicle excise duty. So they're not that cheap. Next chapters were on conventional fuel hybrid electric vehicles, so hybrids like I drive, where you can recover energy. Then a chapter on pure electric vehicles by Al Cairns, who's another lecturer from Oxford, I think. Then a chapter on fuel cells, hydrogen fuel cells, which are an interesting and emerging technology. It's a very simple technology. It's the reverse of the experiment we all did at school, when you put 2 electrodes in a beaker of water, pass a current, and you get hydrogen and oxygen off. If you reverse that, put hydrogen and oxygen together in a membrane and get the hydrogen and oxygen to combine into water, you get electricity given off, and you can use that to drive your electric motor. So it's relatively simple. It's a bit harder to actually make it work, and you need 99.999% pure hydrogen so you don't contaminate the catalytic membrane where that chemical reaction happens. And then lastly, I'm sort of on time to have plenty of questions, there was a final chapter on autonomous vehicles and self-driving cars, or sometimes called self-driving cars, and also what are called intelligent transport systems, where the vehicle interacts with other cars and its surroundings to make them safer. The primary driver for autonomous vehicles is safety, because we can prevent far more accidents from happening. 95% of accidents are caused by human error. Get rid of the human element, you can reduce accidents by more than 90%, which is a good objective. But they can also play a role in reducing vehicle emissions. And this is a really excellent chapter by a group from, I think they're from Oxford, led by Kevin Vincent. And they really talk about the fact that you can optimize the drive cycle, take away control of the accelerator from the driver so that the vehicle optimizes fuel use. You can manage things like congestion, aerodynamics, all sorts of other factors come into play to utilize the autonomous driving systems to reduce emissions. So they're primarily for safety, but you can optimize route planning, get rid of congestion, and you remove control of the powertrain from the driver for optimum efficiency. So here's a nice line of Toyota Priuses. With autonomous driving, they can all bunch up very closely. You get rid of aerodynamic drag. You can make much better utilization of the congested road network. You get more cars on the road, so you don't end up with so many traffic jams and so much stationary traffic. The most polluting vehicle of all is a vehicle sitting in a traffic jam with its internal combustion engine running, because its emissions are effectively infinite in terms of grams per kilometre, because the kilometres are zero. So whatever the pollutants are in grams, you divide the number by 0 and if you divide any number by 0, you get infinity. So you don't want to sit in a traffic jam with your engine running, hence all the stop-start systems that are fitted to pretty much every car today. Very useful for cars, something called platooning, even more useful for trucks. Now, most commercial vehicle operators would bite your hand off for a 3% fuel saving. But when you've got them all closely together, driving autonomously and collaborating with each other, you can close the gap up so you greatly reduce the aerodynamic drag, giving all the following trucks a 10% fuel saving, and the leading truck is still getting a 3% fuel saving because it's actually being helped along a bit by the reduced drag of the truck behind it in the vortex behind the trailer. So platooning for trucks is a really, really valuable technology as we move towards lower carbon emissions. I'm just about at the end now. In conclusion, there are enormous technical challenges in terms of getting to low carbon emissions. And there's been fantastic progress made in the last 8 years since the first edition of the book was published. There's no single technology that's going to get us to zero carbon. While I partially agree with Julia King in her report that the answer is partially electric, it can't be wholly electric. And we need to work on all these other technologies, particularly the synthetic fuels, to address the legacy fleet of existing vehicles if we're going to really make a difference in the next few years. And as we're hearing about COP27, it's really urgent. Now, we've all seen the extreme weather we've had in the last few weeks. Where I live in Cambridgeshire, we've had really intense thunderstorms, hail, very, very heavy rain, strong winds, things that I don't remember earlier in my life. And I'm sure that's climate change. So there's no single technology, but cost is the most important factor. Because if people can't afford the technology, either because they don't have enough income or as a commercial vehicle operator, it doesn't make economic sense to buy the technology, they won't buy it. It's got to be affordable technology. So cost is the most important factor. We need legislation that allows alternatives. I'm quite concerned that the government has said internal combustion engines are banned from 2030. They are picking a winning technology that might not be the right answer. So we need engineers like us to have more freedom to identify better solutions than just saying they have to be electric. So this is a really exciting time to be an engineer. I think there's more going on now than at any time since I started working in the automotive sector over 40 years ago. So it's a really exciting time to work on it. And I find all these technologies really interesting as technical challenges moving forwards. So I said I'd take an hour, that was 50 minutes. I've galloped through. I'll say again, I'm not trying to sell the book. I was just trying to use it to show you that this is a complex question with many, many alternatives that are worth exploring. And that was really the point of writing it in the first place. So I'm happy to answer questions. Thank you.
Thank you, Richard. Let's give Richard a round of applause. So, yes, always on time, as he said he would be. Thank you, Richard. So it's over to you now, audience, for a few questions. Remember, he said he lives in Cambridgeshire now, so we're not going to keep him all night. And if we can wait for the microphone to actually reach you, that helps those with hearing aids to understand the question. So I do see my stalwart regulars, but I'm going to skip you for now because I know you can take it. So I'm going to walk over here. First question.
Good evening. That was very interesting, Richard. You talked a lot about vehicle technology. The other factor, and maybe it doesn't get as much attention, what about improving the roads and road engineers?
Yeah, that's a really good question. Yes, and I did touch on it with the connected autonomous vehicles and having smart infrastructure that makes better use of it. and then we might be able to spend some time repairing it. It's interesting that the government's now gone away from smart motorways. They've backtracked because they're not convinced that they are as safe as motorways with hard shoulders. I think you make a good point. You know, there's plenty of opportunity to improve fuel consumption with better roads, speed humps. They might slow traffic down, but they're disastrous for emissions and fuel consumption. Yeah. So if you had traffic calming with onboard systems that slowed the cars down automatically rather than needing a bump in the road, that would be a major fuel consumption and emissions benefit.
Hi, Richard.
Hi, Chris.
Real good point, I think, about the legislation. How are we going to convince the legislators to take the different approach that we need to look at alternatives?
That was why I wrote the book in the first place, to try and do that. And I've given my pitch on this many times to Department of Transport people. Whether they'll take any notice, I don't know. At the moment, they seem to be erring towards Julia King's electric vehicle report. So we'll have to wait and see. We need more people. Probably. Chris and I used to sit next to each other when we were both in short trousers at Ford.
Didn't realise that was part of the uniform.
Thank you very much. Whenever we talk about alternative fuels for cars, we always talk about the sort of cars you had on your slide there. 5 seats, weigh about 2 tonne, and usually carrying 1 person. The average occupancy is 1.2, I think. When are we going to talk about single-person cars as the main use of transport?
That's a really good question, actually, and I've often thought about that, but I'm going to answer it from a slightly different perspective. One of the reasons that cars are so big and heavy is because of all the safety structure around them to protect the occupants when they run into each other. If we had autonomous vehicles that communicated with each other and we could avoid them ever colliding with each other because there's no human error having the accidents, you can get rid of all that safety structure. And you could literally have the lightest possible, very, very minimalistic car that just keeps the rain out and the wind off for you to drive around in complete safety. I think there is a place for very small single-seaters as well. Gordon Murray's been working on a sort of minimal city car that's getting quite a lot of publicity and traction.
They're actually on Top Gear this week.
Oh, what, the Gordon Murray one?
Well, 3 cars.
Oh, the minimal city cars. And there is a real place for it. But the issue with those at the moment, until we get to the autonomous vehicles that prevent them having accidents, that if you're in the little lightweight city car and you hit a great big 7-seater Mercedes or Volvo, you're going to come off much, much worse. So we've got to get to those autonomous safety systems that prevent the collisions before people will feel safe in those small single-seater minimalistic cars. That's the challenge, I think. But I agree, it's a really good idea to reduce emissions and use far less resources and energy.
Well, yes, thank you, Richard. Yep, well, a couple of questions. One is, comment first. I did respond to the House of Lords Select Committee on hydrogen for both transport and heat, and the submission was accepted, and it was even cited in some discussion, although, truth to tell, they misunderstood the point.
Yeah. Not all that many engineers in there.
No, that's true, yeah.
Engineers don't want to do that job.
I just thought I'd draw you a little more on the numbers for the fuel conversions. You did lightly touch on the point that the direct route utilising the renewable electricity in battery electric contrasted with the synthetic fuel route. But if you could expand a little on the numbers. Thank you.
Yeah, I think the bit you're talking about, Gordon, was where I said using electricity directly in an electric car has about a 90% conversion efficiency.
Yeah.
Whereas if you convert that electricity into hydrogen through electrolysis
Yeah.
and then back into mechanical engineering energy, it's only about 45%. So half the energy efficiency of using it directly in the drive system. And that's a difficult, physical problem. You can't easily overcome that because we don't have particularly high efficiency electrolysis methods at the moment for turning water into oxygen and hydrogen.
True, and I have higher differences. Greater differences.
Right.
Most recently, it was fully charged, and you have seen the videos. Anyway.
When I was in that presentation where Sir David King said, if you're a gambling man, on average, it's probably worth doing something about climate change because you're gambling the future of the planet.
Yeah.
He also said, if you've got kids, you should encourage them to go and study chemistry at a high level to invent a more efficient energy conversion process from sunlight. If you think about it, all of our energy, wherever it comes from, is from the sun. And I didn't mention solar, but the long-term solution is solar, because all of our energy on the planet, be it fossil fuels that have been made from photosynthesis in plants, through to wind and wave and solar, everything else, everything comes from the sun. And David King said you need to get the kids to work out how to more efficiently convert solar energy into a usable form for our needs as a planet. And I think that's a very valid point.
Thank you.
Thank you for your talk, Richard. A subject that's close to my heart, also being on the powertrain systems and fuels group at IMechE. Really continuing on the theme of car size, you mentioned the mass of the car and the aerodynamic resistance, the CV, if you like. But of course, the thing that's really important is CDA. The frontal area of the car, and that defines the aerodynamic resistance. And I think we've found that the downward trend of the vehicle car park has now plateaued out. The downward trend we've seen for the last 10 years has now plateaued out because of the trend towards what I call these Tonka toy cars.
SUVs.
Everybody's driving these enormous cars.
Yes, they should be banned. From a climate perspective,
Absolutely.
nobody should be allowed to drive an SUV. They are socially irresponsible and corrupt.
Well, doesn't SUV stand for socially unacceptable vehicle?
Absolutely right. Yes, absolutely right.
And going on from what the gentleman over there said, I happen to live just off a road where there are 3 schools. And sorry to any mothers that are here, but they seem to try and come down with the biggest possible car they can. Exactly what you said. Why does a mother have to drive 2 tons of car to pick up a child? It's ridiculous.
I used to live in Brentwood, where you live. Brentwood has the highest concentration of Range Rovers in the world. And you should see. Because they're totally unnecessary. They think they're protecting their kids. What are they protecting their kids from when the planet becomes uninhabitable?
Just one last comment. Personally, I don't think hydrogen should be on the starting blocks unless it is green hydrogen.
I tend to agree with that, but as I said, it's really a very split view on hydrogen. It's a very divided view amongst the experts of whether it's a good technology or not, and I'm not sure where I sit on that. Other than I don't think I'll get a chance to drive one while I still can.
Well, it's not for passenger cars because of the efficiency of both.
And it might be the solution for aircraft with synthetic fuels eventually. And there are experiments with synthetic fuels for aircraft. But I tend to agree with you. I think they're too expensive. It's too expensive and not an obvious solution for cars. And if we did have plentiful green, cheap hydrogen, just burn it in an internal combustion engine.
I was interested in your, well, very interesting talk, the whole thing, but you mentioned about the report that electric was the future, but there must be some progression. We're not suddenly going to have everybody in electric cars, or that they seem to talk as though we will by 2030. Is there any idea where's the electricity going to come from?
Very good question.
I've looked up the annual consumption of fossil fuels in the UK and converted the amount of work you get to, say, 40% efficient internal combustion engine, and I'm an electronics engineer background, so with a 90% charge efficiency and 90% motor efficiency, the net result would you would need 8 power stations of the type that, well, the recent one in Pembroke gas fire station, that's, you need 8 3 gigawatt power stations just for the, so it's not going to happen suddenly. We talk about building a power station, and that's what we do. We talk about it.
And it takes 20 years.
It does. So where is this electric? I mean, surely if they keep pushing this, we're going to go to power cuts will become normal, even if the stuff wasn't expensive.
You're absolutely right, but it's even worse than your point. It's not just where does the electricity come from and have we got it enough. Not everyone lives in a house with a garage and a drive so they can have the charging point. So you're going to have cables across all the pavements. That's not going to work. And then, how do you distribute the electricity through the distributed network to charge them? And there isn't capacity to do that either. So it's a really difficult question that they haven't really answered. When electric cars are less than 10%, they're 10% of sales, they're only about 1% of the vehicle population. If we got to 20 or 30%, I think we've got an untenable situation at the moment. So you make a really good point about charging capacity, electricity source. And if the electricity doesn't come from a green renewable source, if you make your electricity in a coal-fired or gas-fired power station, you're not actually much better off than burning the fuel directly in the internal combustion engine because of the energy conversion losses. Don?
Thank you, Richard. First of all, thank you very much for a very nice lecture. I agree with all the points you're making in terms of the fact that pure battery isn't the solution that is suitable for all transport needs, particularly heavy duty transport, where you have a job to do, which is to transport a very heavy piece of equipment or whatever it is you need to transport within a fixed total mass, and therefore the energy density of the fuel is very, very important. Because the lower the energy density of the fuel, the less economical it is within the weight limits and the volume limits of that truck to transport the load. Or in other words, if you are forcibly backing a technology that is very energy undense, you are forcibly making that whole transport system less efficient, and therefore you're aggravating the problem rather than solving it.
Exactly.
So for that reason, you need to look for an energy dense energy carrier that is in itself renewable and sustainable.
You're absolutely right.
I just wanted to quickly chime in on the gentleman about power station back in 2018. I did a calculation similar, just to, I was giving similar kind of lectures in Ford on renewable energy and what are the benefits, pros and cons of electric. And I took all the traceable sources of Office of National Statistics about transport kilometers made and the available energy efficiency of electric vehicles in terms of, energy used, kilowatt hours per kilometer, etc. Mm-hmm. And my rough calculation was that the entire electricity generated today would have to be doubled to replace the transport miles from carbon to electric.
Yep.
And doubling the electricity infrastructure just means whatever we have today, we can't do. And that's in 2018.
I suppose on the positive side, if we don't address climate change, the wind's going to blow a lot stronger, so we get a lot more out of the wind turbines when they turn.
Can I just say, some of you may be aware of it, but on this subject of conversions of energy use and supply, there is a fantastic book online, free, called Without Hot Air, by Professor David McKay.
Yeah, it's one of the best books.
One of the best books you'll ever find on the subject. And he does all of those calculations that you're talking about.
It's an easy read.
Yeah.
It's an easy read, very accessible, but very excellent. Do you have any online questions they have?
I think there's a lot of agreement here on alternative fuels, and now that's a great solution. What do you think the key challenges are, and maybe in addition to that, what can we do in order to try and get something like that adopted?
I was asked about how do we influence the government. Like Gordon, I actually went to the Transport Select Committee, which is a bit like a court of law in Parliament, to give evidence on electric cars after the King Review was presented. And I talked a lot about the economics. I think the economics is really key, because if the technology is not affordable, either for private motorists or the freight transport sector, it won't be adopted. So I think one of the biggest challenges is really cost, getting the technologies to be affordable as alternatives to what people are driving at the moment. It's no good having electric cars that are only suitable for the rich. You've got to have electric cars that are affordable for everyone. And as I mentioned, a Fiat 500, which is one of the cheapest, is still £30,000. That's an awful lot of money. And I can't see any affordable electric cars at the moment that Mr. Average, on average salary, can afford.
What do you see as being the most likely economically viable e-fuel or synthetic fuel alternative out there?
Yeah, that's the question. I mean, biofuel is quite a good alternative. Ethanol made from fermenting wheat. But the challenge there is not so much economic as the food versus fuel argument. That, we can make biofuels if we want people to starve. Well, that's not a very good alternative either. So you've always got trade-offs to make, because biofuels are quite virtuous. I didn't mention them in much detail, but biofuels absorb CO2 when the crop's growing, which is virtuous, and then they're quite good in terms of CO2 emissions. Ethanol is better than petroleum in terms of the emissions when you burn them in an internal combustion engine. So biofuels are really good, but we haven't got enough land mass. And with climate change, the land mass to grow crops is probably reducing, not growing.
Quick question. You had a joke about that you will be too old when certain technologies become available.
Yeah.
Don, obviously, you know quite well. So we've seen the fly grid, we've seen the stop-start, we've seen the hybrids, and totally agree with you about petrol over electric. And we've had conversations with Gordon about our full focus hybrid. Quite clear about Cougar, because we're driving a Cougar and the fuel economy rubbish. But autonomous vehicles, all joking aside, what sort of timescale are you thinking that it become a viable? You're saying we'll get fuel savings if we can go.
That's a good question, because I actually, a couple of years ago, I was giving a lot of lectures about autonomous vehicles, and I thought they would come sooner rather than later. But more recently, we're seeing major challenges in terms of who's responsible, who's liable, what happens if they fail. Although we kill 2,000 people a year on the roads, and we just accept that as a risk of driving a car. And no one challenges that there are lots of fatal accidents every year with our conventional cars that we drive when we put control. We only need 1 or 2 fatal accidents caused by an autonomous vehicle. That's it. That technology's off the table. We're never going to do it. And that's kind of what's happening in America. There have been a couple of well-publicised fatal accidents with Tesla and trials in Arizona where there have been fatalities, where the systems weren't sufficiently developed to particularly identify those driving conditions or recognise a pedestrian pushing a bike. And that's put a major brake on the development of the rollout of the technology. I'm not quite sure how we can overcome that, because I always say, although it's a very emotional subject and it's catastrophic for the people involved in those fatal accidents, we could still save 90% of the 3,000 or 2,000 killed a year in this country through driver error and get 2,000 down to 200 deaths with autonomous driving. And there may be 1 or 2 fatal accidents due to the autonomous system going wrong. Isn't it better to still save those 1,800 deaths versus the 1 or 2 in the autonomous accidents? It's a very difficult argument to have with the general public because they'll only see what they read in the newspapers, and they're not engineers, they're not statisticians.
I think it's concerned about your belief in computers and electronics being safer than you.
So I was a little concerned about you pushing forward the idea and belief that electronics will be safer. I don't believe it at all. I'm an electronics engineer. I mean, just the amount of data that we transfer that's required for a considerable number of autonomous vehicles in one place. So you have 20% of them in London. The amount of data that has to be handled and the power consumption of the data centers that handle it. And where is that electricity coming from?
Well, I thought they were coming sooner a couple of years ago. I'm not so sure now. And there are lots of other reasons. I mean, you make a good point there. It always used to bug me as a mechanical engineer that my systems wore out, but electronic systems don't wear out. No. The reliability of electronic systems is they do what they're told to do and they're repeatable. But if they fail, it's for mechanical reasons because solder joints break. But generally, electronic systems do what they're told to do, and if they fail, it's because we told them to do the wrong thing. So we haven't validated them properly.
Very interesting discussion.
Yeah. I mean, we can have the same discussion about autopilots on planes. You I don't know if you do fly now, but you trust a plane to take off from Gatwick in fog, fly across the world to Australia, and land in Darwin in fog, fully autonomously. And if there's a risk, it's that the pilot touches anything. I used to make a joke that in future, you're going to have a pilot and a dog. And the pilot's there in case anything goes wrong with the automatic systems. And the dog's there to bite the pilot if he touches anything. Because it's more likely the pilot will make an error than the computer systems that we trust at the moment generally don't have some errors.
They evolve slowly, and at any given airport, they land 1 minute.
That's true. You make a good point about the amount of data.
200 cars a minute.
It's the subject of another lecture entirely.
Can I come back to the subject of the electric cars being only affordable by the very rich because they're very costly? I find it hard to believe that we don't have optimism that the price of the electric car can be substantially reduced. If you think of the parts count in an electric car, and I look under the bonnet of a Land Rover or a Jaguar or anything like that these days, there are, and you guys from Fords particularly must know this, there are thousands of bloody parts inside there that have all got a cost. Whereas a battery electric car strikes me as being a relatively simple engineering construction So what are the major cost drivers, do you think, in an electric car?
It's the raw material cost of the battery.
Yeah.
Lithium is very, very expensive to extract, and the magnets. So you do make a good point. And my ex-boss at Ford, who unfortunately is no longer with us, Richard Jones, predicted that in 2026 we'll get to parity of electric car costs with internal combustion engine costs. But he made the point that the reason we'll get to parity is because the internal combustion engine costs will go up so much to meet the emission standards by then that electric cars will then be at parity. They'll still be extremely expensive. And you know, I'm quite comfortably off on my Ford pension. I can't afford an electric car, not a new one. And I wouldn't dream of buying one at the moment. And I see where I live, all of the new houses have electric car charging points. And about half the new houses have an electric car outside, mainly Audis and VWs, very expensive cars. And I wonder, what do these people do where they can afford a £600 a month lease charge?
Not engineers, you see.
Apparently not. Apparently not. And they are very, very expensive. And you know, and you might be able to afford the lease cost. And they probably don't do it for environmental reasons. They want to be seen to be green, and they want their neighbours to see that they've got an expensive electric car parked outside, because they never put them in the garage. They're always outside charging up in the drive from their solar panels. So it's, and as I mentioned, although fuel's quite expensive now, and it costs us £1,500 to £2,000 a year for the average car, that's trivial compared with the capital cost or the lease cost of an electric vehicle.
Richard, we're near the end now, so just invite Peter, who was going to ask a question, and do a vote of thanks as well. But on the affordability, I was just reading online yesterday, so at the risk of losing control of the whole room, apparently to incentivise the good and the great, paying our MPs only £85,000 a year minimum, and subsidising all of their food is not enough. And they should be encouraged to have multiple jobs as well. So maybe that's the route to getting an electric car. Yeah. Never mind, Mr. Average on the average wage of still £26,000, as you said. Yeah. So just before I hand over to Peter, I've been looking at my phone because I want to remember these things. So I just want to do a bit of plugging again for the next two talks, if I may. So on the 23rd of November, Nigel over there, who's away from CSES in the lead, has organised IMechE from Cambridge University Library's Digital Content Unit. It's going to talk about the influence of engineering on the GLAM sector. Sounds exciting. GLAM equals galleries, libraries, archives, and museums. So how are we going to take all the content in galleries, libraries, archives, and museums and digitise it? So that's on the 23rd of November at a 7 o'clock start. In here, Nigel, is that right? Next door. Next door. Mount 221 Lecture Theatre. Okay. And then looking ahead from IMechE side, the 18th of January, as I said at the beginning, Peter Wotherspoon has kindly organised Dr. Alistair Glass from the Royal Observatory to give us a talk on the James Webb Space Telescope, which is producing some amazing images at the moment, and I think that would be really interesting. I think Dr. Glass is based in Scotland, so they won't be coming down to present themselves, but there will be a Zoom meeting hosted here, so we're going to try and do it that way around on this occasion. So I invite Peter to ask the last question and also give the vote of thanks. Thanks, Peter.
Right, well, my question before the vote of thanks was to follow up actually something that Roy just said. I know this is a bit outside your remit, but driving today from Rayleigh, this evening from Rayleigh to Chelmsford, I spent most of my time queuing up in 3 different traffic jams. Now, some people, it's a one-off for me this week, some people are doing this every day, probably twice a day, all over the country. Now, looking at the social aspect of vehicle usage, surely that is unsustainable. And we can't just have these technical solutions without looking at changing the way people use their vehicles.
Yeah, I completely agree. Peter, and I did touch on that with the connected and autonomous vehicles, smart road networks, where if we had enough communications with the drivers and cars, you'd all be routed in completely different directions to make use of all of the unoccupied network instead of all trying to channel down a single road that you know about. So there are technical solutions to reducing the congestion, but we probably should change our work patterns. You know, we did become accustomed to hybrid working through COVID. My daughter only goes into the office twice a week now instead of 5 days a week. And, you know, we should reduce the amount that people travel. But people view travel as a sort of God-given right now. Henry Ford put the world on wheels, and we can't put the monster back in the box now. Everyone expects to go wherever they want, whenever they want. They don't just drive for work, they drive socially, for all of their pursuits and leisure, or just it used to be the pleasure of driving. It's not very pleasurable anymore. Or to come here. So, and this is online, you know, we could have done it all virtually, but I thought, well, and I thought, that's right, given that it's so long since we had a physical meeting, I said, I'll come down here, even though it's 40 odd miles. Yeah, that's true. That's true. It's a good point. I don't disagree.
Okay, Richard, I feel we've been privileged today to have a bird's eye tour de force overview of this subject. So I think Richard has covered nearly every aspect, and even the social part of it, which you've just done. It's a very difficult subject. And going back to 1904, you referred to, it was obviously, a crossroads there for personal transport. We had more electric cars than we had internal combustion cars, and there's also standing steamers, so the steam cars were in the mix as well. So we're at a similar situation now. In the next, between now and 2030 to 35, we're going to come up with some solutions that are workable for everyone. But it's a fascinating subject, and I'm sure we're going to hear a lot more about this in the future. So please join me in giving Richard a big thanks.